Hello friends, and welcome to part 2 of our video on the periodic table of elements. Today we are going to be talking more about the periodic table, about the elements that we find on the periodic table, and how to use the table to determine subatomic structure. So, as we introduced in our last lesson, there are many different elements known in our universe, and they are all organized on what is called the periodic table of elements. You also might recall that they are arranged in a certain order based on their properties, like their mass, their radius, and as we will see here, lots of other properties. So the periodic table of elements, and hence our universe, contains lots of different elements that have an extremely wide range of properties, meaning they have all very different characteristics than others, as well as some elements having similar characteristics to certain elements and then being very different from others. So if we think about what these elements are, we have elements like gold, silver, iron, that are metals that can be used for building things, many other uses. Then we have other elements that are gases, like the oxygen that we breathe, like the nitrogen that also floats in our air, like the helium that we use to fill up balloons. Then we also have other gases, similar in the regard that they're gases, but very different in the fact that they're also toxic and can also be deadly. Then we also have elements on the table that are radioactive. Lots of different elements with very different characteristics. The reason that we talk about this is because the reason for these extremely different properties comes down to something that seems very simple, which is their subatomic structure, meaning the number of protons, neutrons, and electrons that they have inside of their atoms. So simply by having a different number of subatomic particles than another element, we can see such varying properties, which also lead to very different uses. So obviously we breathe oxygen and then we build train tracks with iron. We fill balloons with helium, but if we breathe in chlorine gas, we will die. Okay, so today we're going to look at how to determine the number of subatomic particles that are in each of these elements based on the information on the periodic table. So on the periodic table, we are given some information that can help us to determine the exact subatomic structure of any given element on the table. Today, we're going to find out how to do that by simply reading the information on the periodic table to determine its subatomic structure, meaning the number of protons, neutrons, and electrons that an atom of that element possesses. Now, there are 3 subatomic particles, so there are 3 subatomic particles you should be able to determine using the information on the periodic table. So in our last lesson, we learned what all of these different characteristics are. If you need a refresher on that, please do hop back to our last video to remind yourself. So first, we're going to look at how to determine the number of protons, because that is the simplest step, and that is the step that gets us to the other 2 type of particles. To find out the number of protons in one atom of a given element, you simply need to look at the element's atomic number. That atomic number tells you the number of protons in one atom of that element. For electrons, this step is also very simple, but you should know the why behind it. So for any element on the periodic table, the atoms generally exist at a ground state of 0, meaning that their overall charge is neutral or 0. If we think about a number line, charges work much the same way. In order to end up with a neutral or a 0 charge, I need to have an equal number of positive particles as I do negative particles. If you think of +4 plus -4, mathematically gives me 0. Charges work exactly the same way. All of that being said, finding out the number of electrons is quite simple if you know the why. In order, again, to reach that 0 net charge, I need to have the same number of protons and electrons. So my number of electrons is exactly equal to the number of protons that we found by simply looking at the atomic number. Finally, in order to determine the number of neutrons in an atom, we need to take a look at the element's atomic mass. If we think back to our very first lesson on atoms, we remember that the only particles in the atom that contribute to the atom's mass is the proton and the neutron. We do not consider electrons as having enough mass to actually contribute to the overall mass. Therefore, the atom's mass is made up of the protons in the atom and the neutrons in the atom. In order to find the number of neutrons, we simply then need to take that atomic mass and subtract from it the number of protons. That will leave me with the number of neutrons in the atom. You will see this in the example that follows this slide. However, I will mention it here as well. When looking at your atomic mass to carry out this calculation, you must round it to the nearest whole number before doing your calculation. You cannot have a partial number or a non-whole number amount of something. Therefore, in order to find the number of protons, you must round that atomic mass using the same rounding rules that you use in math.